After acquiring the volatile data, we move on to acquire non-volatile data. Although it is possible to acquire drives from a live system, the most efficient disk imaging approach is using high-speed forensic imagers. At this point, LargerCube's forensic Falcon achieves 30 gigabytes per minute imaging speed, while MediaChron's Super Imager reaches the speed of 29 to 31 gigabytes per minute. The prices of these imagers range from hundreds to thousands of dollars. The imaging process is easy. You simply connect your source drive to forensic imagers to start imaging. The duplicated image in the format of your choice will be stored on a target drive. Some target drives or destination drives are sealed within the imager unit, for example, FDAS by SignLine. Some forensic imagers, for example Falcon, can simultaneously image multiple source drives to multiple destination drives, creating multiplications in different formats. These imagers will have built-in write blocker functionality to ensure that the original drive data will not be modified. Commonly, the left side of the imager connects write-blocked source drives, and the right side connects destination drives if the destination drives are not sealed within the image unit. These imagers will also generate and verify hash values automatically after the imaging. If you do not have a forensic imager, using the combination of software-based imaging tool with a write blocker is common to create a bitstream copy of drives. We saw both DD and FTK imagers in previous units. Besides these two, EnCase Forensic Imager and EnCase Forensic from Guidance Software and Forensic Toolkit from Access Data are among the leading products in drive image acquisition. EnCase Forensic Imager is a free acquisition tool that also provides the functionality of viewing and browsing potential evidence files. However, you will need a write blocker to separate the original drives from the imaging software to prevent software from modifying data in original drives. EnCase Forensic by Guidance Software was the first sophisticated forensic imaging and analysis tool on the market in 1998. When using EnCase to acquire an image, it creates an EnCase evidence file. This evidence file includes headers, content of the original drive or media, and MD5 and SHA-1 hash values. Besides hash values, EnCase evidence format also adds error detection by storing the CRC checksum for every 64 sectors of data. If hashes do not match, CRCs will help find where the changes at the sector level. Older versions of EnCase image use .E01 extension. This extension is recognized as EnCase image file format, also known as expert witness format, short for EWF. Since EnCase version 7, the extension becomes .EX01, known as EWF version 2. EnCase can also create images for files and directories without including slack and deleted data. This type of image is called a logical evidence file format with the extension of LX01. Both EX01 and LX01 format supports for compression and encryption of the data. Although there are other disk image formats, both raw DD image and EnCase image are among the most common disk image formats used in forensic imaging. FTK Imager can convert one type of image to another type of image format. EnCase's other great feature is that it has its own built-in software write blocker to provide a forensically sound write blocking software solution for all connected disks. Hardware write blockers use a hardware device that physically separates your evidence disk from your forensic workstation. What is a software-based write blocker? A software write blocking uses a software application installed on your forensic workstation to prevent the workstation from writing to attached disks. For example, SafeBlock Win8 from Forensic Soft Inc. is a standalone software writing block that can be installed and used with other forensic acquisition tools. EnCase has its own software write block called FastBlock SE that is built into the EnCase software. Here are the steps of using EnCase's built-in FastBlock SE write blocker to acquire a subject device. First, make sure that the subject device is not connected before we turn on the write block option. Launch EnCase Forensic and create a new case. And then select Tools, FastBlock SE. Select the Plug and Play tab with Write Blocked option. Insert a USB or other devices for imaging. Click Close. With FastBlock SE turned on, you will have no risk of modifying the source evidence when you acquire device image. So far, we have assumed that forensic examiners always know which drives or partitions they should acquire. However, since acquisition is a long, time-consuming process, examiners would like to go through multiple drives to decide which one is most likely to contain critical evidence. This is called previewing the evidence. EnCase and FTK Imager let you preview drives before acquiring them. This means you only read data but do not own the data. Preview allows examiners to quickly determine whether relevant evidence exists on a computer before going through a long acquisition process. Remember, you have to use a write blocker for imaging as well to ensure you do not change a single bit on the drive when viewing the files. Finally, we will discuss remote live forensics with the capability of acquiring memory and drive data from a remote machine in a forensic sound manner. Several commercial solutions like EnCase Enterprise, Mandiant MIR, and F-Response are able to gather live information from a remote machine through the agent pre-installed on the remote systems. Google Rapid Response, GRR, is a powerful open-source incident response framework focusing on remote live forensic acquisition and analysis. GRR uses a client-server architecture. Agents are installed on all the clients that frequently communicate with the server to receive tasks and send task results to the server. The servers are responsible for sending requests to the clients and collecting information from the clients. GRR includes both TruthKit and Rekor. Its memory acquisition and analysis functions are provided by Rekor, and then its disk and file system analysis functions are supported by the TruthKit. Although using GRR for remote forensic acquisition and analysis is not required to pass this course, it is a very powerful tool for forensic investigators. In this unit, we covered Windows volatile and non-volatile data acquisition process and technologies. In the next unit, we will look at Windows file system and registry.